All right, you ready to grade it? Check it out. Good. By the way, actually, let me go back. For tomorrow's test, these are the items you need to bring with you. Make sure you have your own stuff. You need a pen. I mentioned on the first day of school, the only reason you need a pen in this class is for a test. So tomorrow you need a pen because you're taking a test. You need a pencil for all graphs and drawings that you are asked to construct. You need a ruler so you can measure things. It's not a straight edge. You need a ruler because you will be asked to measure things on the test. And you need a calculator, obviously, to do your own calculations. You cannot share materials with another student. All right, that is not allowed. If you do that, both you and the student you are sharing with get zeros on the test. So don't do it. All right, questions? Okay. And then, of course, I mentioned to you the videos that are due on Thursday from Unit 2. All right, here we go. Let's check starting on page 21. Number 1. This bullseye is target C. This bullseye is target A. The next is D. The last one is B. Save all your questions till the end, okay? Let me get your answers to the entire thing first. Number 2, measure the lengths of each of these and how many sig figs are in each. So letter A is 6.40 centimeters, or you're allowed within 0.2 centimeters, but you do need to have the correct precision. So if you did not measure out to the 100th of a centimeter, that would be marked wrong. So anything between 6.20 and 6.60 centimeters is allowed, so long as you went to the 100th place. And that has 3 significant figures. Letter B, the accepted answer is 10.25 centimeters. Again, you have to measure to the 100th place. You should have had a unit on it. You're within 0.2 of a centimeter, so anything between 10.05 and 10.45 centimeters was allowed, as long as you measured out to the 100th place, and that has 4 significant figures. Number 3A has 2 significant figures, and in scientific notation, that would be 3.2 times 10 to the negative 3 millimeters. You do need a unit at the end of every number that you record. Letter B, that is 3 significant figures, and in scientific notation, that is 3.81 times 10 to the 4th power kilograms. Letter C has 3 significant figures, and that is 7.01 times 10 to the negative 4th power seconds. Again, make sure you're ending all of these answers with the unit, seconds. Letter D has 4 significant figures, and that would be 3.600 times 10 to the 1st power meters per second. So notice when we rewrite them in scientific notation, we keep the number of significant figures. You don't drop digits. Letter E has 1 significant figure. So in scientific notation, that would be 4 times 10 to the 2nd power, and the unit is capital N. Number 4, carry out the following unit conversions. So in letter A, we're going from milliseconds to kiloseconds. So these are the 2 conversion factors we need, where milli is 10 to the negative 3 and kilo is 10 to the 3. So using our factor label method, the first thing we're going to do is take our given value and put it over 1. So 5.5 milliseconds over 1. We're then going to multiply by 10 to the negative 3 over milli, or 1 times 10 to the negative 3 over milli. And then that way the millis cancel. Now I'm going to multiply by the kilo over 10 to the 3, or 1 times 10 to the 3. I punch that all into the calculator, and I get 5.5 times 10 to the negative 6th power kiloseconds. Let's go to the next problem on the next page. Letter B. 81 nanometers is how many gigameters? All right, so we look up the prefixes. Nano is 10 to the negative 9th power. Giga is 10 to the 9th power. So those are the 2 conversions we need. We start by taking our given value, 81 nanometers, and we put it over 1. We need to cancel out the nano, which means in the next fraction, nano goes in the denominator, and the 1 times 10 to the negative 9th power goes in the numerator. Now I have to multiply by the giga. So giga goes in the top, 1 times 10 to the 9th power in the denominator, which gives me 8.1 times 10 to the negative 17th power gigameters. Letter C, 12 decigrams is how many picograms? So the prefix deci is 10 to the negative 1 power. The prefix pico is 10 to the negative 12 power. So again, we set it up, 12 decigrams over 1. We're going to multiply by the fraction that cancels the deci. So deci in the bottom, 1 times 10 to the negative 1 in the numerator. And then we're going to multiply by the pico conversion factor. So pico in the top, 10 to the negative 12, or 1 times 10 to the negative 12 in the denominator, which gives us 1.2 times 10 to the 12 picograms. Number 5 is asking you to solve each of these equations for the variable x. So in this equation, we have PES is 1/2 kx squared. We're going to divide both sides by 1/2 of k first, which leaves me with PES over 1/2 k is equal to x squared. Now I have to take the square root of both sides. So my final equation for x is the square root of PES over 1/2 of k, or if you prefer, when you divide by 1/2, that's the same as multiplying by 2. So you could have had the square root of 2 times PES over k. Letter B, we have to divide both sides by the negative k to isolate the x. Gives us f over negative k is equal to x. In letter C, to solve for x, the first thing I have to do is get the y squared out of the denominator. So I'm going to multiply both sides by y squared. So that gives me 3 plus x is equal to z times the y squared. Now I have to get the 3 out of there. So I'm going to subtract it from both sides, giving me x is equal to z times y squared minus 3. In letter D, I have to cross multiply this thing out first. So that gives me y squared is equal to z times the quantity 3 plus x. Now I have to divide both sides by z, giving me y squared is 3 plus x. Now I'm going to subtract 3 from both sides, giving me y squared over z minus 3 is equal to x. All right, 6 or 8, we're going to use our guess method. So in number 6, these are the values that I'm being given, 4 m over s and 12 kg m over s. I'm asking you for mass. This comes from the mechanics page of the reference table. So when we list our givens, we should have listed that v, a speed, is 4 meters per second, and p, which is momentum, is 12 kg m over s. The unknown is lowercase m. We look for the equation and we get the equation P equals mv. This one I have to do the algebraic manipulation of because it is not solved for m. So the equation for m is P over v. Do you have a pass? Yeah. It's in securely? Yeah. Okay. All right, so now I'm going to go ahead and do my substitution with units. So I'm left with m is 12 kg m over s over 4 m over s. Notice the m over s's are going to cancel because it's in the top and the bottom, leaving me with an answer of m equal to 3 kg. That has the appropriate number of sig figs and a unit attached to it from the substitution. Now I have to do my dimensional analysis. So I'm going to analyze the equation I plugged into, m equals p over v. So we start with this one, but really that's the one we do our dimensional analysis on, the one where I plugged everything in. So I have kg is kg m over s over m over s. And here I see those m over s's cancel, now leaving me with kg on both sides, and that checks. Number 7, we should have circled these 3 measurements, 8.5 m over s, 4s, and 6 m over s. You should have underlined the word acceleration. Again, this is from the mechanics page of your reference table. And the variables are VI, which is 6 m over s. That's the starting or initial speed. VF, which is the ending speed, final speed, 8.5 m over s. And T, which is 4s. The unknown is A. The equation I used to solve was A is change in V over T. A change in something is always the final value minus the initial value over T. I'm now going to substitute in, which gives me 8.5 m over s minus 6 m over s over 4s. Of course, when I do the subtraction in the numerator, you get 2.5 m over s over 4s. So I'm going to round my answer to one significant figure, which is 0.6 m over s, or m over s squared. Now to do the dimensional analysis on the equation I plugged into, A is change in V over T. I said that A was in m over s over s. Well, the V's are in m over s, and the T is in s. Both sides match, so I'm good. Number 8, we should have circled 0.5 capital A, 4.5 ohms. I'm looking for underlining the word power. This comes from the electricity page of your reference table. You should have identified the letter capital I as 0.5 capital A, and R, capital R, is 4.5 ohms. You're looking for capital P. That's your unknown. So the equation you should have selected from that page of the reference table was P equals I squared R. You then should have substituted in 0.5A, that quantity squared, times the quantity 4.5 ohms. When I multiply this out on the calculator, I have to round it to 1 sig fig because of the 0.5, which means my final answer is 1, and the units are capital A squared times ohms. When I do my dimensional analysis, I'm checking P as I squared R. So I said that P was in A squared times ohms. I squared is A squared, R is ohms. Notice both sides of the equation match, so that's good. All right, last page of the review. So first thing I want you to do is graph the data. So this is the graph. This is what you should have had. A graph titled velocity versus time. If you left off a title, obviously that's going to cost you points on the test. You also have to have the title in the proper order. Velocity first, time second, because of how they are placed in the data table. Now you have to label each axis with the variable. The y-axis should have been labeled velocity in m over s. The x-axis should have been labeled time in s. Let me see if I can zoom in at least a little bit. It's a little bit better. Now you got to check for scaling. And remember, you want to spread it out as much as you can. On the horizontal axis, since I need to get up to 5 seconds, starting from 0, I did every 1, 2, 3, 4, 5 lines was 1. That gives me a pretty nice uniform scaling, and it gets me all the way to 5 seconds on the far right. On the vertical axis, I have to get to at least 110 m over s. Remember, I want you to use as much of this graph space as you can. So I picked a scale that got me actually to 200 m over s, which is fine. I need to go to at least 110. If you can go beyond it a little bit, that's great. So when I do that, I did every line was 10. So that's, and I'm labeling every other line, 0, 20, 40, 60, 80, 1, 120, 40, 160, 180, 200. Then I plotted my data points, 1, 2, 3, 4, 5, 6 of them. I then drew a nice best fit diagonal line that is linear. I don't see any kind of curving happening here. Then, Notice I've got points above it and below it. All right, that's best fit. We do not connect the start and end point. That does not mean best fit. You have to try to figure out where is the middle of all that data. Part B, well, that was draw the line of best fit. Part A, what is the relationship on that graph? You should have said that the relationship was direct. If I asked you for the shape, what would you have said? Diagonal line. Very good. Okay, letter B, I did that. Now I want you to find the slope of this line of best fit. So you got to find 2 points that are on the line, not necessarily data points. So if I had done the slope calculation using that data point right there that I'm pointing to, that would be wrong because it's not on the line. Likewise, if I use that point, that would be wrong as well. I actually look at your graph and I look at the 2 points you're plugging in. And if they're not on the line, you lose full credit for the slope calculation because you didn't find the slope of a line. You found the slope of points, which doesn't exist. There are no slopes for points. It's slopes of lines. So the points you plug in have to be on the line. So I'm showing you my givens, the 2 points that I selected. And remember, I taught you to number them. So I'm using this as 0.1, and that's going to be my 0.2. Notice that's not a data point, and that's okay. 0.1 should have for me, had a value of 0 seconds and 10 m/s. 0.2 has a value right here of 2.8 seconds and a value of 70 m/s. I'm looking for m. I then have to write my full equation, left and right sides. M equals y2 minus y1 over x2 minus x1. You have to have that equation memorized for tomorrow. It's not going to be given to you on the test. You need to know it. And you have to have the m on the left side. If you just said y2 minus y1 over x2 minus x1, that's not an equation. An equation has both a left and a right side with an equal sign in between. So without the m equals, that's not an equation. That would be marked wrong. Now we're going to go ahead and plug in the points that I just indicated with their values. 70 m/s minus 10 m/s all over 2.8s minus 0s. I then do my intermediate subtraction. So I get positive 60 m/s. So that has 1 sig fig because of the precision of the data. And over that 2.8 seconds, which has 2 sig figs. So I'm going to round my answer to 1 sig fig because of the numerator, which gives me positive 20 m/s over s. Part C wants you to write the equation for this line of best fit. So we're going to start with y equals mx plus b, and now we're going to change out every letter. On the y-axis, you should have said that you had velocity. So velocity equals, then you're going to plug in the slope with its units, positive 20 m/s over s. The x, you should have changed to the word time, plus the y-intercept. The y-intercept for my graph was 10 m/s. All right, any questions? Anything at all on the review that you want to go over? Any of these questions at all before we continue with Unit 2? Yes, Nikolai. Yeah. I just want to try something out. Yeah. Can you see that all right? Yeah. So on tomorrow's test, the way these questions will be worded, I'll tell you what the language would be. Okay. Because I'm very explicit on what I need to say when I write the directions to these show work questions. So the questions would say, show all work, including, and then afterwards I tell you what I need to see. If it's not in that list of including, you don't necessarily have to show it. So for this problem, what would it have said? It would have said, show all work, including the givens, unknown, equation. For this problem, substitution, with units, actually I would have said, and substitution with units. Be sure to express your final answer with appropriate units and significant digits. Now, this step, I will usually ask for separately. And remember what the check is called. Do you remember what a check step is called? 2 words. No, not direct analysis, dimensional analysis. So if I want you to show the dimensional analysis, it would say, and show the dimensional analysis to prove the units of acceleration equal the units of change in V over T. Something like that. Okay, so if I say that I want to see dimensional analysis, you see that phrase, and it will tell you, prove that this equals this. Then you show it. If I don't say you have to show the dimensional analysis, you don't need to do it. If you do it, you would not lose credit. You're just wasting time on the test where you could be doing other problems that are actually going to be graded. You follow what I'm saying? And on this first test, you may find that you're not really sure how much time to spend on things. So you want to pay attention to the directions on each question to make sure you're showing what I need to see and not necessarily more than what I need to see. Do you know what I mean? Just because I don't want you to run out of time. If you run out of time, I can't give you extra time on this test. It means you weren't reading directions or you don't know the subject as well as you thought you did. Emma? It's a 40-minute test. Half the test is always multiple choice. So it's 100 points. So 50 points out of the 100 comes from the multiple choice. The other half is from the constructed response questions. All right. Constructed response, there's partial credit. Multiple choice is it's right or it's wrong. And the only things you get to correct back for extra credit after the test are multiple choice questions, not constructed response. I always encourage you to go back and look them over, but I won't give you points back for the constructed response. This test has 10 multiple choice. So 10 multiple choice should take you no more than 20 minutes. And if you're a good test taker, you can probably get them done in 5 minutes because you don't necessarily have to work things out. You can do things through process of elimination. That can't be right. That can't be right. That can't be right. Boom, it's got to be this. Most of the multiple choice is designed where you don't need a calculator. The calculator part comes on the constructed response.
Can you show where you got the equations for 7 and 8?
Yep. So on your reference table, right? So 7 talks about changing speed. That's not anything dealing with electricity. It's not anything dealing with a wave. It's not anything that Albert Einstein came up with. It's definitely not geometry or trigonometry. So we go to mechanics. And there's the equation for number 7, that A is a change in V over T. You could have also used this one. VF is VI plus AT. It's actually the same thing. And then you move it around for A, and you get VF minus VI over T. So if you use that equation, that's okay as well. Okay, that's 7.
Are you going to leave like the equation where it is?
No, you have to do the algebraic manipulation. So this one, because there's an algebraic manipulation step, in the directions, it would say be sure to, including the givens, the unknown, the equation, the algebraic manipulation, and the substitution with units. So I'm going to tell you to do it. And if you don't do it, then I'm taking off. Okay, because each of those steps is points on the test. So a question like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is a 10-point question without the dimensional analysis. That one problem right there is worth 10 points out of 100. Because I'm giving you 1 point for each given. Actually, maybe it's 9. 1 point for each given, 1 point for the unknown, 1 point for selecting the correct equation, 1 point for doing the algebraic manipulation correctly, 1 point for plugging in the values, 1 point for the final answer, 1 point for the correct sig figs on the final answer, and 1 point for units on every number that was ever written down in that question, everywhere. So if you forgot to put that M over S after the 4, you just lost that point for the units. It's units everywhere. It's an all or none point. It's not did you write half the units down? Did you write all but one unit down? It's did you write them all down? It's either all right or all wrong. Believe? For multiplication and division, it's the fewest sig figs. You count sig figs. If it's addition and subtraction, you count decimal places. We go to the least precise. Well, because at the end you're dividing by 4. That's your final step. Order of operation says you have to do the subtraction in the numerator first. We always hold off doing sig figs till the end. All right, so at the end we're going to round whatever we get to 1 sig fig because of the 4 in the division. Yeah. Did it approve? Anything else you want to ask on the review? Yeah. Okay, 8 is talking about light bulbs and circuits and currents. That's electricity. So you're going to go to the electricity page. And we're looking for an equation that has I, R, and P in it because we've identified our givens and our unknown. So all our equations for capital P are here. The only one that has the I and the R together is that one. P is I squared R. Okay. Okay, this is multiplication. This has 1 sig fig. That has 2. So your final answer must be rounded to 1. Yep, Emma. Yep. 5D. You want me to go through that one? Okay. So we're trying to solve it for this, for the x, right? Okay. So since the x is in the denominator of the fraction, we have to do our crisscross cross multiply first to get it out of the bottom. So that would be y times 1. And over here, I would have z times that whole thing. Okay. Now, I'm not going to show the times 1, right? That's just the same as y. So now if I want to get this x isolated, the first thing I have to do, because these are inside parentheses, I have to undo this multiplication between z and that quantity. I got to get the z out of there first. Okay, so I'm going to divide both sides by z. So that gives me y over z is 3 plus x. Remember that addition is commutative, so that's really the same thing as y over z is x plus 3. So now how do I get the x by itself? I have to subtract this 3 from both sides. So that would give me y over z minus 3 is x. And that's our final answer. Does that make sense? Right? Was it y squared? Yeah, so just put a square on that. It doesn't change anything other than that. But thank you. Put a y squared everywhere in there. Yep. Yeah, because you missed it. Here, I'll give it to you. Anything else? Yep.
Is that a measurement question?
A measurement question. You want to measure something? Okay. What can I give you to measure? All right, pull out your reference table. Turn to page 4. Look at this chart. We all have that same chart in front of us. Can you measure the width of it? The width would be from here to here. So you need your ruler. My ruler has a clear 0. I don't know if yours does. If it does, it makes your life a lot easier. I'm going to measure from the left to the right edge. Now, because I have tenths of centimeter marks, I can go out to the 100th of a centimeter. That's the correct precision for this tool. So you're going to measure it out. I'm lucky because I have a camera here, so I can zoom it in. You will not have a camera when you're taking your test, so you have to do the best you can to zoom in to count those little lines and figure out how far you are between. The issue with my camera, of course, is it's going to introduce some parallax error, so I still have to look straight down at it. So since I'm starting at 0, I see that this is 6.1. Looks like I'm between the first and the second little line. So I'm going to guess how far I am. I'm almost at the second line, so I'm going to say that's about 6.19 centimeters. We give you 0.2 of a centimeter leeway. You do have to go to the hundredths place. So if I said the accepted answer, as I just mentioned, if I said it was 6.19 centimeters, the first thing I'm looking for is, can you express that to the correct decimal place? If you didn't write it to the hundredths place, I don't care what you wrote down. When you're subtracting?
Yeah, like if I just wrote the same thing for that.
All I'm going to do is ask you for the final answer. I'm not going to ask to see the work on that because everybody has a different ruler, and I'm assuming many of you have rulers that have a clear 0 at the end. So you don't have to show subtracting 0. All right. So I'm going to check, first of all, does your final answer go to the right decimal place? If it does, then I look, is it within 0.2 of a centimeter? So that means my answers that I would accept when I'm looking at this are between 5.99 centimeters and 6.39 centimeters. It would have to be in that range. If it's not in that range, then I also mark it wrong. Okay, so I'm looking for something between these, but it has to go out to the correct decimal place precision. Does that make sense? That's what I'm looking for. Anything else? Yes. Yeah. You want me to make up a new one? Yeah. Okay. A 3N net force is applied to an object, so the object accelerates at hold on a minute, come back, change this number. I'm just making numbers off the top of my head. I want to make that 4.2 N. So a 4.2 capital N net force is applied to an object. So the object accelerates at 2.1 m meter. I'll write it out because you're going to see it spelled out. No, you won't. M over S squared. For now, we're just going to abbreviate the units. What is the mass of this object? And I want you to use your guess method. I'm not going to give you the full instructions. Let's use the guess method to do that. So the first thing I want us to do is circle the things that you know. What things should we be circling? You see any values in there we should circle, Miriam? 4.2 N. And 2.1 m over s squared. What should I underline? What word? Yep. All right. Which page of the reference table do you think this question is going to get solved from? Yeah, the mechanics page. So everybody should look at page 6. Now we're going to start with our givens. The first measurement we have is 4.2 capital N. What is that a measurement of? It's a measurement of something called net force. Look at page 6. Can you tell me what symbol we use for that, Ryan? Yep, F net. F subscript net. The next value that you circled was 2.1 m over s squared. What is that a measurement of according to this problem? Elise, can you help me with that? What's that a measurement of? Yep. And according to page 6 of our reference table, what letter are we going to use for acceleration, Jan? Lowercase a. All right, those are the only measurements we know. Now we have to identify the unknown variable that we're looking for. Alex, can you tell me what that letter would be? M for mass. All right, now you got to look for the equation that contains those three things, F net, A, and M. Audrey, you got it? That is it. This is an equation known as Newton's second law. It's a huge topic in our course that we'll be studying a lot more about later this year. But is this solved for M? So you have to do the algebra. Since M is in the denominator, we got to get it out of there first. So that means I would have A times M is F net. And then I'm going to divide both sides by A. So M is F net divided by A. Are we good so far? Now we're going to do our substitution with units. So M is 4.2 n divided by 2.1 m over s squared. All right, now you go to your calculator. Divide that out. What do you get? Calculator says 2, but does that have correct significant figures? No. How many do I need? 2. So what am I going to write it as? 2.0. What units do you want to put on this based on the substitution? N over m over s squared. You just leave it. You want to do the dimensional analysis on this just to double check? Okay, so we are going to check the equation we plugged into. Only if the question says to do it. Okay, you're only going to show me stuff that I tell you you need to show. Remember, you're going to have that big including statement. That's the equation we plugged into, the manipulated one, so that's the one we have to check. What is the unit for m that we came up with? N over m over s squared. What unit did we have on the variable for F net? Capital N. What unit did we have for the variable A? Okay, am I talking Russian? Thank you. What do you notice about the left and right side? So it's done. Okay. I know it's early in the morning, but when I ask you a question, it's not rhetorical. I do need you to respond back. Yes. You know the answer. Even if it's an easy question, answer it. Be glad it's an easy question because there are going to be some that will be doozies later on. All right. Hold on one second. Just wrap up this.